All right.
Hi everyone, thank you for attending our presentation titled, What Are We Really Drinking?
So today we have with us Amateur Professor Olson, Amateur Professor Onright, Amateur Professor Sen, and Amateur Professor Sherwin.
So, all of us go to the Commons, and when we go there, a lot of us choose to drink water. But we don't really know what that water is. When you go in there, you could choose to drink either from the bucket labeled filtered water, or from the soda machine. You can pull the little lever on the lemonade faucet. But we don't really know what's happening to that water when it comes out of the tap. Like, is it really filtered? We don't really know. So we're going to find out. So we assume that both the filtered water that we could drink and the soda fountain water both come from the tap somewhere. But is it really just straight out of the tap? We don't know. So our goal is to find out, and then we'll be able to find out which water choice is a cleaner option and what is happening to our water.
So what we're going to do for control is use the tap water that's behind spec. So there's a sink or so that we're thinking that's going to be the source for all the waters that we're going to be testing using these different filter systems. We also we just bought a filter system that we're going to be using to kind of test to see how well these other filters do, so we can see if we're actually getting real filtered water in Spexel. And then for fun, we got a sample from the mill pond before winter, so we didn't have to worry about contaminants from the salt from when it starts snowing, and we won't have to worry about raising get runoff from those salts to affect our ion concentrations. So it's going to be fun to see how different the concentrations are between the mill pond water and the regular tap water, and how that also the differences between the filtered water and the tap water.
Also, we did hire a Sodexo worker to get us tap water from the sink in the back of the Sodexo kitchen, so we can ensure that the water there aren't any differences from getting it from any other tap on campus. Also, we can compare how Sodexo's filter matches up against the commercially bought filter, so we can test their performance.
From these samples that we're collecting, we will be testing for lead, cadmium, fluorine, and nitrate ions. We're testing for the lead and cadmium ions because they're heavy metals that are commonly found in water, and filter companies such as Brita advertise that they can remove these ions from the water. We're testing for chlorine and fluorine because these ions are also commonly found in water. Fluorine is added to municipal water sources and commonly talked about in regards to city water. And lastly, we are testing for nitrate ions because they're common in Wisconsin water due to farming runoff, and it is expected to be very abundant in the mill pond water.
So obviously, once we collect these samples, we need some way of testing the concentration of these ions. So atomic absorption spectroscopy using standard addition is a great way to test for metal ions. So we'll be using the AA for lead and cadmium to test for the concentrations in each of the samples. And then for fluorine and chloride, we'll form precipitates, dissolve them in water, and then we can use titration to find the concentrations of those two ions.
So since nitrate absorbs light within the UV-Vis range of the EM spectrum, we will be using UV-Vis spectrometry along with the calibration curve to determine the concentration of nitrate within our water samples. But because the water samples that we obtain can have different ions within the concentration, that will affect the UV-Vis absorption if we just place the UV-Vis spectrometer alone. So instead we will be using HPLC to separate the nitrate ions from the water sample, because HPLC can separate the ion within the water sample for us, and it can also put it through the UV-Vis spectrometer because it's already built into HPLC.
Questions?
Questions, comments, concerns?
The nitrate on HPLC is problematic, but there is a way to complex it to get the UV-Vis data. It's hard to separate that on the type of column that's typically on an HPLC. There are ion columns, but we don't have an ion detector for the HPLC. So we might, there are these little packets that have reagents in them that you can use for nitrate. But it would still be UV-Vis, but it's complex to something. Any other questions?